Hi everyone, my name is Sauvé and I'm a PhD student at Lancaster University in the UK, and I'm very proud to present our paper, A Change of Perspective, How User Orientation Influences the Perception of Physicalizations. So first of all, what is a data physicalization? It is a physical artifact whose geometry or material properties encode data. So there's already a lot of work out there in the field of physicalization, and two of the key benefits of these kind of systems are that it allows for collaboration and it provides opportunity for spontaneous interactions. However, these benefits rely on a key assumption that physicalizations effectively communicate information in all directions and to all users equally. But people might interpret data differently depending on what side of the physicalizations they are viewing. So the consequences of this are profound, as it could make physicalizations ambiguous and could lead to incorrect interpretations. So we propose a systematic approach to create a better understanding of how the orientation of an individual influences their perception of data. So the core research question that we try to answer with our work is: how can we develop a better understanding of the relation between user orientation and the perception of physicalizations? To investigate this relation, we designed 6 example physicalizations, and the design of these is informed by the well-known bar charts that are often used in this field. Each of the physicalizations consists of 16 objects and vary in 4 lengths, and we did this to create a range of complexity but also keep them similar in density. The layouts of the 6 physicalizations were created by applying 3 different visual properties that are known from 2D visualization. So first of all, we applied proximity, and this was used to create differences in internal and external distances between the objects, and also to create 2 different types of spatial relations, so either in a grid or linear fashion. Secondly, we used continuity, and we used that to create differences in perceived connectedness between the objects, either by using objects of similar size or placing objects of increasing size in a consecutive manner. And lastly, atomic orientation, which was used to create differences in the orientation of the individual objects, either in the X, Y, or Z plane. So for the purpose of our study, we intentionally created physicalizations containing edge cases of different properties, so they were open to more than one interpretation. For example, if we look at Phys1, according to the proximity between objects, it is one cluster. However, if we would look at continuity, it could either be 4 clusters of constant size or 4 clusters of consecutive size. So to evaluate the user responses across perspectives, we presented each physicalizations from 4 orientations, and we called them north, east, south and west. And this was to cover the major viewing angles. We recruited 20 participants to perform tasks for each orientation of each physicalization, so in total they saw 24 physicalizations each. To go a bit more into detail on the exact 3 tasks that the participants did, we applied the information retrieval tasks that are known from 2D visualization. So first we asked participants to identify clusters of objects, and the terminology we used for this was: can you identify any groups of objects? Second, we asked them to indicate any anomalies and asked, what is the group that stood out first to you? And lastly, we wanted them to find any extremum that they saw by asking the question, can you point out the highest and lowest value or values? So for each of the tasks, we asked the participants to clearly point out the objects with their hands to capture exact location and structure of the identified clusters, anomalies and extremum. So to be able to use our data to talk about the influence of orientation on the perception of physicalizations, we introduced the terminology orientation consistency, or OC. With OC, we mean the consistency of user responses to information retrieval tasks across different orientations. So in this specific study, as we looked at 4 orientations, we categorized 4 different OC values from 1 to 4. To give an example, if a participant completed a task, for example clustering, different across all orientations, they would get assigned an OC value as 1, as there's no consistency in how they performed the task across orientations. Likewise, a participant with OC value 3 means they completed the task consistently across 3 out of 4 orientations, meaning they were more consistent, but not 100%. We applied this method to evaluate the consistency in user responses across tasks, participants, and physicalizations. So what did we find? Our results show that user perception is directly affected by orientation, which might not be a surprise. But to give an idea of the extent of this influence, if you look at the first 2 columns of this table, in case the participants were consistent across all 4 orientations for each of the tasks that you see here, the values would have been 100%, whereas clearly they are not. But it goes further than this. The influence of orientation actually created a systematic lack of consistency, not only across tasks, but also across participants and across physicalizations. So why did this happen? We found that occlusion is one of the main reasons for these inconsistencies. And I will explain 3 types of occlusion that we observed by means of the clustering task. So the first type that we observed was continuity occlusion, which occurs when a set of objects seems to be intersected, which prevents someone to see the full continuity. For example, for Phys 3, in a north orientation, a cluster of 3 cubes was identified, as one of the cubes is occluded. However, in the east orientation, the continuity of the cubes is not occluded, as you see by the 4 green objects, and therefore they led to a cluster of 4. Then we also saw proximity occlusion, which occurs when the perceived distance between objects appears either further or closer together, which prevents someone from seeing the true proximity. For example, for Phys 5, in the east orientation, the objects were perceived as 3 clusters. However, in the south orientation, the front left cluster occludes the objects in the back, so they seem closer together and therefore they were perceived as one larger cluster. And lastly, atomic orientation occlusion, which occurs when objects of different forms are perceived similar, or when objects of similar form are perceived different due to their atomic orientation. So if you look at Phys 4, in the west orientation, the objects were clustered by size. However, in the north orientation, objects of different size were perceived similar due to the perspective of the viewer, leading to one larger cluster. And the 3 objects in the back that are very different in their orientation led to a smaller second cluster. So if we zoom in a little bit more on the effects of orientation on anomalies, we observed 2 different themes. So first we saw that participants more likely observed non-occluded objects first, so for example the tallest objects, or objects that were very distant from others. And the second theme that we saw is that there was a relation between the clustering exercise and the filtering of anomalies. So for example in Phys 2, in case participants identified the diagonal, tallest and minimally occluded objects as anomalous, this also showed in their clustering of the physicalization, as they would cut it into 2 clusters by the diagonal line. And then if we look at the effect of orientation on perceived extremum, we observed in general that participants would pick the smallest and largest objects, which you see in the light and the dark blue cubes in the example on the left. However, if you look holistically at the different extremum that the participants found, we saw 3 different behaviors. And I will explain that by using Phys 2. So the first way that we saw is that participants chose one single object as extremum for the entire physicalization. The second behavior that we saw was that they would assign a cluster of objects as a collective extremum. Or lastly, they would assign an extremum within each cluster that they identified. So to conclude, our work provides first insights on the variability and complexity of the relation between orientation and user perception. Our empirical findings show that, at least for these conditions, physicalizations cannot communicate information in all directions reliably, which breaks one of the fundamental aims of physicalizations. With our work, we would like to encourage others to design physicalizations that take perspective into account, and to use orientation consistency as a measure to see how successful the physicalization is in communicating information across perspectives. And with this, I would like to thank you for your attention, and in case of any questions, feel free to contact us. Thank you.